Now let's continue with the next property. The limit of a quotient is the quotient of the limit. Let's say we have the limit when x approaches to a of f of x divided by g of x is equals to the limit when x approaches to a of f of x divided by the limit when x approaches to a of g of x. Then it's going to be equals to L divided by m. Assuming m is different from 0. Remember, we never can have 0 in the denominator. Okay. Now we need to identify which one of this one is going to be f of x and g of x. F of x is x plus 1 and g of x is equals to x plus 2. Then the limit when x approaches to 2 is going to be, the limit when x approaches to 2, x plus 1 divided by x plus 2 is the same if I write it this way. The limit when x approaches to 2, x plus 1 divided by the limit when x approaches to 2 of x plus 2. Now this is equals to, I can plug in the value right now. Then the limit when x approaches to 2 of x plus 1 is equals to 2 plus 1. And in the denominator is going to be 2 plus 2, which is equals to 3 divided by 4, 3/4. Then the limit when x approaches to 2 of x plus 1 divided by x plus 2 is equals to 3/4. Now the last property. The limit of a constant times a function is the constant times the limit of the function. Let's see. The limit when x approaches to a of c times f of x is equals to c times the limit of f of x. Okay, we need to identify which one is the constant and which one is the function. In this case, we have the limit when x approaches to a of 3x. Let's say the value of a is 4. Now, which one is going to be my function and my constant? The number 3, remember? All the numbers are going to be my constant. And x is going to be my function. Just to identify the values, I'm going to say c is equals to 3 and f of x is equals to x. Then what I need to do, I need to multiply the limit when x approaches to 4 of 3x is going to be equals to c, which is 3, times the limit when x approaches to 4 of f of x, which is x. Then the limit when x approaches to 4 of 3x is equals to 3 times the limit of x, and I just need to plug in the value here, and I'm going to have 4. Then the limit when x approaches to 4 of 3x is equals to 12. Let's say we want to find the limit when x approaches to 2 of 2x squared minus 4x plus 3. Well, we can use all the properties the properties are available for this example. What do we have here? Well, we are adding how many functions? 1, 2, 3. Let's say the first function is f of x. The second function is g of x, and the third function is h of x. Remember the property. If we are adding different functions, then we can find the limits of each function and then we just add them. But which other properties are involved in this exercise? For example, the first function is 2x. But when I have a constant, if you remember the property number 6, it's the same. We put aside the number and then find the limit of that function. But therefore, there is another property here. We have x squared. This one is the same as the product property. And the product property tells me if I have a function multiplying times another function, it's the same. I find the limit of a function times the limit of the other function. Okay, let's start to find the limit. We're going to separate this, and we're going to find the limit of 2x squared. When x approaches to 2, the limit of 2x squared is equals to. We're going to use this property. We're going to put aside the number 2, and then we're going to find the limit when x approaches to 2 of x squared. And this is equals to, okay, it's going to be the limit when x approaches to 2 of 2x squared. Now we have the 2. And remember, when we have this property here, that means it's going to be the limit times the limit when x approaches to 2 of x times the limit when x approaches to 2 of x. And finally, we have the limit when x approaches to 2 of 2x squared is equals to 2 times, just plug in the value, 2 times 2. And this answer is 8. Okay, the first limit is equals to 8. Let's continue with the next part. We have minus 4x. Okay, as you can see, we have this property here. Now what do we need to do? This is equals to minus 4 times the limit when x approaches to 2 of x. Then the limit when x approaches to 2 of minus 4x is equals to minus 4, and then we just plug in the value. Then the limit when x approaches to 2 of minus 4x is equals to negative 8. Finally, we have the last one. And the last part is the limit when x approaches to 2 of 3. Then, as we remember, this is this property. The limit of a constant is the constant. Then it doesn't matter. We will continue with the second part of the property of when I have just a number, and my next limit is going to be the same number. We just need to add all the answers. The limit when x approaches to 2 of 2x squared is 8. The limit when x approaches to 2 of minus 4x is negative 8. And the limit when x approaches to 2 of positive 3 is equals to 3. Then we need to add the answer. Let's say the limit when x approaches to 2, 2x squared minus 4x plus 3 is equals to positive 8 minus 8 plus 3. Then the limit when x approaches to 2 of 2x squared minus 4x plus 3 is equals to 8 minus 8, 0 plus 3, 3. And this is going to be my limit. Okay, we can summarize all of these properties in this theorem. For any rational function f with a in the domain of f, the limit of f of x when x approaches to a is equals to f of a. How can we understand this? Let's say we want to find the limit when x approaches to 2, the same function we already did, of 2x squared minus 4x plus 3. But now we're going to use this theorem. The theorem tells me I'm going to evaluate in any value of x the value of a. That means 2 times 2 to the second power minus 4 times 2 plus 3. Then the limit of x when x approaches to 2 of 2x squared minus 4x plus 3 is equals to 2 to the second power is 4 times 2 is positive 8. 4 times 2 minus 4 times 2 is negative 8 plus 3. 8 minus 8 is 0 plus 3 is 3.